In this video, I am going to explain to you about Euclid's division lemma. Now, this is a very simple thing which you might have been listening and learning for a long time. I am just reiterating some points. What this Euclid's division lemma says is that for two positive integers, now these integers could be anything, but they have to be positive. If there's a negative integer, then this does not apply. For two positive integers a and b, okay, and this could be anything. So let's say, for example, I say 19 and 6. These are two positive integers. So let 19 be equal to a and 6 be equal to b. For two positive integers a and b, there exist unique integers q and r, okay, which we will see, which satisfy a is equal to b times q plus r. Now this might sound a little difficult, but I will make it easy for you. Whenever we divide one positive integer by another, what happens? Either it completely divides it, or there could be a remainder. So if I divide 19 by 6, what will I have? 6 times 3 will give me 18. I subtract 18 from 19 and I get 1. In mathematical terminology, we call this as a remainder. This is the quotient and 6 is the number which is dividing 19. Now in my example, I told you that 19 is a, 6 is b, okay. What is q? Q is the quotient, right? And r is actually nothing but the remainder, right? So what it says is that for every two positive integers, if there are two positive integers which are taken together, which is 19 is equal to a is 19 is equal to b, which is 6, times the quotient. What is the quotient here? 3, plus the remainder, which is 1. Okay. So Euclid's division lemma says that for any two positive integers, the formula a is equal to bq plus r holds true, where a and b are the positive integers, q is basically the quotient with which we multiply b, and r is the remainder. And the other rule which follows here is that r is always greater than or equal to 0. It cannot be negative. In our case, it is 1, which is greater than 0, and it is less than b, right? What was b in our case? It is 6. So r is less than b. R is 1 in our case. It's less than b, right? And this property holds true for any numbers of two positive integers. If you want, I can give you another example. So let's say we have two numbers, 17 and 5. Now 17 can also be written as what? Can 17 be divided by 5? No. So if you just start multiplying by 5, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and 5 times 4 is 20. Now 20 is more than 17. So we just write 5 times 3, which is 15, and if I divide, or actually subtract 15 from 17, I get 2. And this is nothing if you just, you would have simply divided 17 by 5, you would get 15 minus 2. The remainder is 2. So I have written it over here, just putting in the values in the format, the remainder plus 2. Q is the quotient, which I have put in from here, and 5 is the b in my example. A is equal to 17. Again, if you notice, r in my example is 2, which is greater than or equal to 0, but less than b. What is b in our case? 5. This is what Euclid's division lemma is all about.